We are going to prove that by using properties of triangles, you can find the height of anything.
See this flagpole? Using no more than a mirror, a measuring stick, and triangles, we can find the height. Oh no, please, this method is true. We can prove it to you. You can measure it afterwards.
Here is the diagram for our indirect measurement. To indirectly measure the height of the flagpole, we placed a small mirror with an X in the center on the ground. This is represented by the point X. Then I stood in line with the mirror and flagpole and moved backwards and forwards until I could see the very top of the flagpole through the mirror, and it was touching the X on the mirror. The top of the flagpole is represented by point F, and for future reference, that point remains F, even if the frame is cut off. You can see that the dotted lines represent my line of vision as it reaches the middle of the mirror and bounces off. This forms two equal angles, since it bounces off in the middle of the mirror.
Because the person moves to where they can see the top of the pole, it will be the same angle.
Movement wouldn't affect these angles, though. We measured the distance in centimeters from the flagpole to the mirror, which is bx, the distance from my feet to the mirror, which is px, and my eye level, which is ep. Here are those measurements in centimeters.
They are also right triangles because the person and the pole stand perpendicular to the flat ground, as you can see here. As we said before, because the mirror bounces off at the same angle, these angles are equal. And because they share two equal angles, which are EPX and FBX, and also PXE and FXB, we can assume that they are similar due to AA similarity. Because they are similar, their sides are proportional. We can then say that the corresponding sides are EP and FB, and also EX and FX, and also PX and BX. And now start off with normal equation. You may want to draw model triangles just so you keep the same proportions. Now you can start off with the proportions. You come out to about 488.235. It came out to about 488.2.
See, we have our work. Now you can measure the flagpole yourself.
An average school flagpole is about 20 to 45 feet or 600 to 1,350 centimeters tall.
It came out to about 488.2 centimeters. When you compare our indirect measurement to your direct one, they're extremely close.
But we must realize that human error in terms of measuring may be present.
It is true that there may be possible errors with completely accurate measuring, but for the most part, our conclusion makes sense.
You must now see that this is a valid method.